We did it. L'Hôpitals. We're here. We're going to be able to go back to limits now. Aren't you excited? Because this is what we find out. We get to L'Hôpitals rule. The indeterminate forms. And we're going to start evaluating limits again. And I know you're excited. You're like, oh, I've been waiting forever. Oh, it's been so long since we've done limits. I can't wait. Well, we're back. And it's going to be a little bit different now. There were some things we couldn't solve before. We just hadn't learned how to solve before. And let's give you an example, just right off the bat. A limit. Say we're going to take a limit as, say, x goes to 0. Maybe let's call this e to the x minus 1 over x. Cool. Cool. Now go do some algebra. What are you going to do? Hit it with a conjugate or something? Just plug it in. You find out you get 0 over 0. Oh, weird, like that thing that's written at the top. You try and break it up into pieces. Try and use the old limit laws and algebra. With a little something like this. You try and evaluate that. Using limit laws and some algebra. Breaking up the numerator. Problem is this back end right here. That doesn't exist. This one, you're going to have a heck of a time. You're probably going to have to graph that thing to take a look and see where it's going. Or use some fancy little tricks. Still, you're not going to really find out too much about this problem. Well, that's where L'Hôpitals rule comes in. We are going to explore. We'll get to this next piece, and we're going to see what we're going to do. So if we were to plug this in, I'm going to write a little... I should have had this in here before. I'm going to write this all up. I really shouldn't write 0 over 0. That's bad news. That's bad news. So I just put in like quotes around it, like kinda. So if we were to plug this thing in, wouldn't it kind of be 0 over 0? That's going to be our first case for L'Hôpitals. So let's explore what we got here. L'Hôpitals rule. Ooh, lots of words. Let f and g be differentiable functions where g prime of x does not equal 0 near x equals a except possibly. Okay, ignore all that shit for right now. All right, yeah, lots of freaking words. Cool. So you got the limit of something over something else. Now, what I had showed you back there was we had what was up top, so we had the limit as x went to 0. And our function up top was e to the x minus 1. And our function down below, well, that was just x. So that's the example. That's what it's talking about here when we have this these crazy notations, right? Just saying we got something over something. And if it produces a form where you get a, right here, 0 over 0. Isn't that what we started off with right there? 0 over 0, 0 over 0. If it produces one of these indeterminate forms, and we have other ones too, it's not just 0 over 0. It's also, you can have infinity over infinity, or a negative infinity over a positive over a negative, or a negative over a negative. Just as long as you have some infinite over infinite, we can still use this rule. So hopefully you're hanging on. No big deal, just saying if you plug in the freaking number, you plug in the 0 in, you get 0 over 0. Cool? Now we're saying that we can use this rule. All right, and here it is. It says that you can just take that it's equal. It's equal. That limit that we just started off with is equal to just take the derivative of the top and take the derivative of the bottom, and it's actually the same freaking limit. That is good news. So that's saying we can just take a derivative of the top, the derivative of the bottom, and by the way, we are not saying no quotient. Don't do that, please. No quotient rule. This is just saying take the derivative of the function up top. Take the derivative of the function down below, and it's still equal provided the limits exist. So let's go through. Let's see if we can't do this right here, right on this slide. What's the derivative of e to the x minus 1? That's just e to the x. Now what's the derivative of x? It's frickin' 1. Holy shit, plug it in and you get an answer. You get e to the 0th power. E to the 0th power is equal to 1. Hallelujah, we found it out. And how much work was that? It was pretty simple, pretty straightforward. L'Hôpitals rule is dope. It's gonna get crazy though pretty soon. So there's our lead in. We're gonna come back, have a bunch of these problems for you, running them through, get your practice because these are tricky.